So in the last lecture we have seen how to find out the RMS or and average value of voltages and currents in the half wave rectifier. Okay. So you will see in this lecture the more analysis of half wave rectifier, like the efficiency, okay, the form factor, ripple factor are there. Okay. So in details we'll see these parameters in case of a half wave rectifier. Okay. So first one is your form factor, ripple factor. So what is the form factor, ripple factor? The form factor is defined as the ratio of RMS value of the RMS value of the to the average value. So it may be voltage or current. So RMS value of voltage or current to the average value of voltage or current. Okay. So you can see it is the form factor. So it's the RMS value of current. You can take RMS value of voltage also. So average value of current. So I RMS by I average. So I RMS equal to IM by 2, I average equal to IM by 5. So you can get it will be IML can cancel out. So it is 5 by 2, 1.57. So this is our form factor. Similarly, peak factor is defined as the ratio of peak value to the RMS value. Peak means the maximum value. Okay. So we can take maximum value of the voltage or current. Similarly, RMS value of the voltage or current. Okay. So peak value by RMS value. So peak value is your IM. Then IM by 2 is the RMS value. So it will be 2. Okay. So form factor in case of half wave rectifier is 1.57. Peak factor is 2. Okay. So output frequency is same as that of the input frequency. Okay. So F out equal to F in. So you can see this is the V input. Input means SC. So you can see this time period is 0 to 2 T. Okay. You can see the time period is 0 to T. So the cycle actually repeats for every T time period T. So in this case also, so this is our T. The cycle repeats for every T cycle. Okay, the waveform repeats for every T cycle. So you can see the same. So that is why the F out equal to the output frequency is equal to the input frequency in case of the half wave rectifier. Okay. So now that how to do the rectification efficiency. Okay. So rectification efficiency means so what we are getting at the output, we are getting the DC out means DC value as the output, and we are giving the SC as the input. So the output is your DC, the input is your AC. So it will be the ratio of DC output power to the AC input power. Okay. So the efficiency is your DC output power delivered to the load divided by AC input power from the transformer. Okay. So we are giving the power means input through the transformer. Okay. So PDC by PSC. So the DC power delivered to the load. So DC power equal to IDC square into RL. So IDC or I average. So it will be IM by 5 whole square into RL. Okay. Similarly, the input power from the transformer. So it will be power dissipated in the diode plus power dissipated in the load resistance. Okay. So it will be IRMS. Okay. So IRMS, that is the thing. So it will be I square into R. So IRMS square into RF plus RF. Okay. So we can get this one. Okay. So let us divide both. So the IMS into RF plus RF. Okay. So it will be PDC divided by PSC. Okay. So the efficiency is here PDC divided by PSC. So this we have got that. So that I will get cancelled. So we can get that is the 0.406 divided by 1 plus RF plus RF. Okay. So that in this case the RF is very smaller than RF. Okay. So we can get it is RF can be neglected in this case. So that will be 0.406. So the efficiency is 40.6%. Okay. So similarly we have the ripple factor. So ripple we know what is the ripple? Ripple means the output AC component present in the DC, that is known as your ripples. The pulsating output of a rectifier contains the DC components as well the AC components. The AC components are called the ripples. The ripples are undesirable and there should be small s per possible to make the rectifier effective. Okay. So this ripple must be as smaller as that possible. Okay. So the ripple voltage or current can be measured in terms of ripple factor, which is defined the ratio of effective value of the AC component of the voltage or current present in the output to the DC or average value of the output voltage or current. So this is the formula for finding out the ripple factor. Okay. So the effective value of the load current is given by. So this is I square equal to IDC plus these are the RMS values. So you can see our AC values. So IDC square plus ISC square. So these are the RMS values of the means current, this fundamental, second or fourth harmonic. Okay. ISC square, the sum of square of the RMS value of the AC components. Okay. So we can have the ripple factor is your ISC by IDC. So we can get I square minus IDC square root over divided by IDC. So IRMS square, IRS divided by IDC square whole square minus 1. So this is K. IRMS by IDC is the K for the form factor. So you can see that this is the gamma is the ripple factor. So it will be form factor square minus 1, that is the root over. Okay. So for half wave rectifier, we know that Kf equal to 1.57, that we have seen. So what will be the ripple factor? That will be 1.57 square minus 1 root over. So that root over we can get 1.21. So this is our uh, ripple factor in terms of half wave rectifier. Okay. So next is a transformer utilization factor. So it is the transformer rating becomes necessary while designing the power supply. So we have the transformer utilization factor, which is defined as the ratio of power delivered to the load to the AC rating of the transformer of the secondary. Okay. So you can see the transformer utilization factor equal to PDC by PSC rated. So this is the transformer. So IDC square into RL is the DC value of the power divided by that is transformer rating, that will be secondary of the transformer, that RMS into IRMS. So for half wave rectifier, IDC is equal to IM by 5 square into RL, that secondary transformer this RMS value equal to VM by root 2. Okay. So I am talking about the transformer, that is why it is VM by root 2. Then IRMS equal to, that is IM by 2. This is why taking for the half wave rectifier. Okay. This is the means transformer. Okay. This is the output of a half wave rectifier. So that is IM by 2. So we can get this one. Okay. So we know that Vm is equal to Im into Rs plus Rl. Okay. So therefore we can put over here. So we can get this type of equation. So here also we can means put that Rf is less than equal to Rl. Okay. So this transformer utilization factor is 0.286. Okay. In case of a half wave rectifier. Okay. The regulations, what is regulation? The variation of DC output voltage as a function of DC load current. Okay, is called the regulation. So it is the percentage of regulation is given by Vn, the no load. Okay, minus V full load. VFL is the full load, and VNL is the load, no load. Okay, so Vn is the no load voltage, VFL is the full load voltage. That is how we can means calculate what is the regulations. Okay, so these are the parameters we have seen. Okay. Then what are the advantages? So you have the input circuit in half wave rectifier because we are using only one diode here, or that means it is a low cost. Okay. The disadvantage is that the ripple factor is high. Okay, in case of the 1.1. Okay, the ripple factor is high, and the filtering required to give the steady output voltage. Okay, rectifier means we are getting more ripples in the output. Okay, that is why the elaborate filtering is required. Okay, for the getting the constant DC supply. Okay. Similarly, rectification efficiency is also low because the power is delivered only on the half of the input side. That is why the rectification efficiency was also low. Okay. It is 40.6%. Okay. The transmission utilization factor is also low, it is 0.28. Okay. 208. So that is the uses of half wave rectifier. So we have the is not satisfactory for general purpose power supply. So this type of supply can be satisfactory for some particular purposes like the battery charging. Okay. So these are the uses of the half wave rectifier. So we have seen the details of half wave rectifier. Okay, the how the half wave rectifier works with means with the input combination, that is half wave positive positive values of the half wave rectifier. Okay, and half wave input and negative value of the half wave cycle. Okay, then we have seen how to analyze means how to calculate the RMS value and average value of the input voltage, sorry, output voltage, output current. Okay, then we have seen the form factor, ripple factor. Okay, then the efficiency of the rectifier. Okay, so then we have seen that how to transfer for utilization factor also. Okay, so that's for the half wave rectifier. In the next lecture, we'll see some problems regarding to the half wave rectifier. Okay, then we'll move to the full wave rectifier. Okay. So thank you for watching this video. If you have any doubt, you can free to ask me in the comment section. Okay. Thank you.